Okay, we already got a start on the graphic organizer yesterday, but I'm going to briefly show the video what we covered. We are in Chapter 10, Quadratic Equations and Functions. And so these were the four major sections that we put down yesterday, and I'll be coming back to this as we begin each, right? But we started with graphing quadratic equations by graphing them, just plain old graphing, and then solving by graphing. So yesterday we looked at this first section where we were solving a quadratic function, and we talked about the pieces of it. Part A, or A, tells you whether the parabola opens up or down. We also know that it can tell us if the parabola has a vertical stretch or shrink. C gives you the parabola's y-intercept, right? And B can shift the parabola left and right. Also, B is used to find what important point?
Vertex.
The most important point, right? The vertex. Good. And we use B in the little equation x equals? Good, negative B over 2a. So there we have some info, and we'll come back later for those who weren't in the class yesterday. But we also compare quadratic functions, equations, functions, to the parent function, the most basic baby quadratic equation there is, y equals x squared. And when we do, we can name all those transformations that you were just naming. The A affects, can reflect it with a negative, or it can stretch or shrink it vertically, right? The C translates it up or down, and the B translates it left or right. So yesterday we did one, I believe, after, we said what are the four synonyms for what you get when you solve a quadratic equation? And the first one is, I don't know if there's a first, but one of them is x-intercepts, that's my favorite. And then we have roots and
Solutions.
there you go. We have four synonyms, the best one probably being x-intercepts, the most common one probably being solutions, right, of a quadratic function. When we graph them, we said we find that vertex using that equation we were just talking about. That should be there. And then we plug that x value back into the equation to find the y value of the vertex. And let me leave that there. We usually like to put the vertex in the center of the table so that we can find points that are equidistant to the left and to the right of the vertex, because they will have the same y values, right? And we ended up graphing this equation yesterday, and I'm not going to stop to do that today. So if you didn't do that, you'll need to make sure you complete that. We're in the second section today talking about solving quadratic equations using square roots and completing the square, which is a relative of taking square roots, right? So first, if it's possible, you may be given a rather simple quadratic equation, and if you are, you can just take the square root, right? So what type of a quadratic equation may you do this for? No B, good. So you have the ability to isolate your x squared and just take the square root. So this example shows you no bx. B would be 0, right? And you saw 3 of these on the quiz. And some of you made it harder than it is, right? Because what really is the simple step to solving this? Ellie? Add the what? Okay, good. She says add 54 to both sides. And you have 6x squared equals 54. And then? Good. And then what do you do?
Oh, yeah.
X equals 9?
Yeah.
Oh, not x, but x squared. And you take the square root. Good. And x equals?
3.
Good. And some of you have been telling me that x equals just 3, right? Don't forget, if you made that mistake, that you correct that for this coming test, right? That you know that a square root can be either positive or negative. Okay? So this is great if you have a simple equation without bx in it. But what about when you have bx? Now is when we use that other method called, completing the square. Now, these rules for completing the square look really tough for somebody who hasn't had the practice that we've already had. We're going to write the rules down and then we're going to do one, okay? So what is the goal of completing the square? Well, the goal ultimately is to get the solutions, right? But that's it. The little in-between goal is to get the perfect square trinomial, right? And so we do that by coefficient. Good, good. Kate's jumping ahead. But first we want to make sure that the x squared term has a coefficient of 1, just to make it easier to find the perfect square trinomial. And then, if it's not a perfect square trinomial, as she just said, you would take half of b and square it, add that to both sides. This creates a perfect square trinomial. The perfect square trinomial will be factored to the square of a binomial. And that is something that we can take the square root of. So we do. Take the square root of both sides. It's a more sophisticated type of square root, but it does simplify the equation really quickly. And then we just solve for the unknowns. So here's your equation to try completing the square with. So the first thing we would do here, Kate Patosa?
You have to make the coefficient equal to 1, right?
Good.
So to divide.
That's right. So what will you do?
Um,
Divide by?
Divide by 2.
Good, good. So this is one way you can show your division. Remember, you must divide every term. Okay? And we have a squared plus 6a minus 2 equals 0. And the next step. You look at this and you say, is this a perfect square trinomial? We have a perfect square in the first term, but the last term, not a perfect square. It's negative to begin with, so that doesn't help you. And it's 2. So what will we do? Add 2 to both sides. Now, if this was a bigger number, this might be a factorable equation, and we could just factor and solve it, right? But 2, the factors of 2 are just 1 and 2, and it will never subtract to be 6. Okay, so this is not factorable. So we're going to add 2 to both sides to make room for completing the square. And I do leave a little room there, so we can plug in the number that will complete the square. And what will that be, Johnny? We're looking for the number here that will make this a perfect square trinomial. Good, 9. So it's half of 6 squared, which is 9. Don't forget, we're adding that to both sides. Some of you have found the correct number to complete the square and then forgot to add it to the right side. Okay, so be careful. We now may write this perfect square trinomial as the square of a binomial, right? Which is what, Jeff? Good. Good. Okay, so we achieved the goal of getting this squared term. And now what do we do to both sides? Good, square root. So we end up with the beautiful little a plus 3, so easy. And square root of 11 to the 10ths would be what? Do you have that? 3.3?
Isn't it 3.67?
3.6? Are you using a calculator?
3.67, possibly.
Well, plus or minus 3.3. Okay, Ellie, what do we do to finish this?
Subtract.
Subtract 3. And tell me the 2 expressions we get.
You get, oh wait. Oh, and then, oh yeah, 3.3 minus 3 and then negative 3.3 minus 3.
So 3.3 minus 3 is 0.3, and negative 3.3 minus 3. Good, that's the easier one, negative 6.3. And what do these numbers tell you? X-intercepts. They're points on a graph, don't forget. Okay, now we are looking at solving the quadratic equation using a quadratic formula. The quadratic formula has a special piece in it, right, called the discriminant. So these two topics are in panel 3. So go ahead and jot down the quadratic formula. Ready? X Good, and we're just going to use it. So go ahead and use this equation to practice using your quadratic formula. Come back and check. Okay, so here we have it. If you need to pause and take a look at the work, we had a beautiful 64, easy to take the square root, and we have 2 points on the graph, 2 x-intercepts. Okay, good. In this same section, because we were talking about the quadratic formula, we are going to talk about the discriminant, which helps us tell how many whats? How many solutions, right? X-intercepts. So the discriminant is the square root of what? It's just b squared minus 4ac, right? The discriminant is really just that expression. I like to show the radical that it is found in because it comes down to the fact that you can't take the square root of a what? Negative, right? There's no real number. So if this value in here is less than 0, how many solutions does this equation have? None. And so it's a parabola that opens up and it's above the x-axis. Or it's a parabola that opens down and it's below the x-axis, right? What if the discriminant equals 0? Because the square root of 0 is one thing. It's 0, right? So you would have one solution. These are graphs that have the vertex touching the x-axis. Okay? And finally, what if you have a positive discriminant? 2 solutions, because you can take plus or minus of a positive number, right? The square root of 1 is plus or minus 1, right? Square root of 4 is plus or minus 2, and so on. So find out how many solutions are in this quadratic equation. Okay, so when it comes down to this equation, how many solutions? 1. Good, because the square root of 0 is 1 solution. Okay, final section. We were comparing the big equations that we have graphed and worked with this year. Linear, exponential, and quadratic. Okay, to sum this up, you know what we have to do is shut the door. Somebody? We have these equations. Okay, linear equation. Show me with your arms what it looks like. Very good. And you know it's linear because the x value is raised to the what exponent? First. Good. Exponential, show me with your hands. Draw one. There it is. Hank does the best one. Okay, and so it's like a C shape, right? And the exponent is the x. Exponential. Quadratic, show me with your arms. Touchdown. And there you go. So remember we said that you can find these given to you 3 ways. You can receive it as a graph. You guys are really good at identifying what it is when you see the graph. Okay? You could get it as an equation. You're pretty good at identifying it there too. Or you could get it as a table of points, and that's when you want to look for these patterns. In a linear equation, you find the same addition or the same subtraction between successive y values. In exponential, you're multiplying by the same factor between your y values, or you have a ratio that's the same. And quadratic